السلام عليكم ورحمة الله وبركاته. أنا دكتورة آلاء إسماعيل، هبدأ معكم إن شاء الله Physiology of Hematology course. هنبدأ إن شاء الله. دي أول محاضرة Introduction about the blood. So we're going to start. What is the blood? The blood is classified as a connective tissue. So when we said any system, when we said we should know what is that system or tissue exactly. So what is the blood? The blood is a connective tissue. The types of tissue of the blood is connective tissue. Like other types of connective tissue, it consists of cells and intracellular substance and plasma. This is the main component of the blood. So when we say the blood composed of two things, plasma and cells that contain intracellular substance. What is these cells in the blood? Anybody know what is that cells in the blood? We have three types of cells. We have red blood cells, or the other name erythrocyte. We have white blood cells or leukocyte, and we have platelet or thrombocytes. Those only three types of cell in the blood. We need to know the amount of the blood that circulate in the body. The total amount or volume of the blood circulate in the whole body is 5 liters in the average adult male. When we say average adult male, that means 70 kilogram male. This 5 liters is 80% of total body weight. So this is the total amount of the blood circulating in whole body. The volume of the plasma is about 3.5. That means the plasma occupied more than 50% of the blood, and it is 5% of the total body weight. The cells in the blood can be separated from the plasma by centrifugation. What is the centrifugation? Centrifugation is the device used to separate the plasma from the cells. Because as we said, the blood contains plasma and cells. So when we need to separate blood to cells and plasma, we use centrifugation. Why we need that? Because sometimes we need to do blood test in the plasma separate and in the cells separate. So we're going to see that later on, what that blood test or that investigation. We need to separate the blood to cells and plasma. The percentage of the cells in the blood is called packed cell volume or hematocrit. What is the hematocrit? The hematocrit is the percentage of the cells in the blood. So when separate the blood to plasma and cells, the plasma is about 70% and the cells is about 30%. That 30% is called packed cells volume. So we're going to start to talk about the plasma. The plasma is a fluid part of the blood. Volume, as we mentioned, is 5% of the total body weight in 70 kilogram adult male. It's about 3.5 liters. What is the content of that plasma? The plasma, it contains water, 90%, inorganic substance and organic substance. The inorganic substance like minerals, sodium, potassium, calcium, this is the electrolyte, and it contains minerals. And also contains organic substance. Organic substance like proteins, glucose, fat, bilirubin, urea. We have many. Any substance or any organic substance, you hear about it in investigation, in introduction of the physiology, it found in blood. Anything in our body, we found it circulating in the blood. So when we take blood sample, when we need to investigate some substance like sodium, potassium, proteins, liver function test like enzymes, anything, we take it through the blood. That means any substance in our body circulate through the blood. any hormones we needed to go to the tissue like the kidney, to the thyroid, it go through the blood. Any substance we needed to go to the heart, it go through the blood. So in the plasma we have water, inorganic substance and organic substance. The most important organic substance in the blood is the proteins. The proteins, we have 3 types of protein, don't forget it. We have albumin, these are most important proteins in the blood. We have globulins, we have 3 types of globulins, alpha, beta, and gamma, and we have fibrinogen. So this protein, anything circulate in the blood, synthesized in other organ or in the other tissue. So we start with the plasma protein, where it's synthesized. The synthesis of the protein occur in the many organs. We have the first one, the liver, synthesize most plasma protein, and the most important one is the albumin. And we have the plasma cells. The plasma cells synthesize the gamma globulin, which are synthesized in the lymphoid tissue. What is the plasma cells? The plasma cells, it's the P lymphocyte. When the P lymphocyte become mature cell, it's called plasma cell. And plasma cell synthesize the gamma globulin. What is the gamma globulin? It's the immunoglobulin. Immunoglobulin G, immunoglobulin M, immunoglobulin A, immunoglobulin E, and immunoglobulin D. So all these immunoglobulin or gamma globulin synthesized in the plasma cell, and the other types of protein synthesized in liver. Okay, so the total concentration of the plasma protein is 6 to 8 grams per deciliter. The albumin is 3.5 to 5. That means most of the plasma protein is albumin. And the percentage of globulin, 2.3 gram per deciliter, and fibrinogen is the least plasma protein, 0.3 gram per deciliter. What is the function? What is the functions of that plasma proteins? The main functions of the plasma protein is the oncotic pressure. I think all of you know about it. You take it in the hemostasis course in the introduction of the physiology. We have oncotic pressure. We have hydrostatic pressure and we have oncotic pressure. That pressure maintains the extracellular and intracellular volume and maintains the hemostasis. So the oncotic pressure comes from where? From that plasma protein. And which plasma protein exactly? It's the albumin. Why is the albumin? Because the albumin is the higher concentration of the plasma protein in the blood. It's the smaller and larger in number than the other type of the plasma protein. So the oncotic pressure maintained through the plasma protein, and the most important one is the albumin. So we're going to start to talk now about the cells in the blood. The cells is, as we mentioned, the cells in the blood can be separated from the plasma by centrifugation. What is the BCV? The BCV is a percentage of the blood occupied by the cells. The RBCs, the WBCs, the platelet in the blood, it's called packed cell volume. When it's separate from the plasma, it's called packed cell volume or PCV. BCV. What is the percentage of that BCV? It's 40 to 50% in the male and 37 to 47% of the female. That means less than 50%. Low BCV indicate anemia and high BCV indicate polythysemia. So I expect to find question here why we call low BCV anemia and high BCV polythysemia. Anemia mean low hemoglobin or low RBCs, and polythysemia high hemoglobin or high RBCs. But the BCV it's not for RBCs, just for RBCs, it's for all cells. Why we call low BCV anemia? Because the RBCs, it's the most the higher percentage of the cells in the blood is RBCs. So the RBCs occupied higher percentage of cells in the blood. So these pictures for the centrifugation of the blood in your left, this is the blood. When we put the blood in centrifuge device, the blood separate to the plasma in the upper because it's fluid. We have a Buffy code. If anyone see the centrifuge, the Buffy code like it's puffy, like white in color. This contains WBCs and platelet. And here, notice the packed RBCs. It's almost 90%. Most of the PCV is RBCs. So, what is the functions of the blood? The functions of the blood. The blood is the most important tissue in our body because without the blood, the heart cannot survive, the kidneys cannot survive, the liver cannot survive, the lung cannot survive. Why? Because anything we needed for that organ or tissue, either nutrients, either oxygen, carbon dioxide, anything for that organ to be functions through the blood. Okay? So without the blood, our body will die. Okay? So what is the functions of the blood? The most important and the first one is transport function. So the blood transport gases. The blood take oxygen for the tissue and remove carbon dioxide from the tissue. The blood transport nutrient for surviving of that tissue or organ like glucose, amino acid, and free fatty acid. The blood take waste product like urea and uric acid. The blood delivered hormones, catecholamines, insulin, cortisol, thyroid hormones, any hormones on our body, transport to the target tissue through the blood. So this is the first functions of the blood: transport of the gases, transport of nutrients, transport of waste product, and transport of hormones. The second functions of the blood: defense against infection and any foreign antigen through the WBCs. So any infection, anything foreign antigen enter our body through any part, through the mouth, through the nose. So this is the functions of the WBCs: defense against infection and foreign antigen. So this is the second functions of WBCs. Without WBCs, the infection, we cannot defend against infection. That is why people with that immunocompromised people cannot survive for long, because there is no defense against anything. Okay, so this is the second function of the blood, and you're going to know more in the immunology course, okay, about that functions. The third function is homeostasis. We have homeostasis, we have hemostasis. You should differentiate between two. We have homeostasis and hemostasis. What is the homeostasis? The homeostasis is maintenance of constancy of internal environment through the extracellular fluid, like control of the temperature. So the blood, if we have high temperature, there is a many mechanism like vasodilation, like increases sweating. So this function occur through the blood. Without the blood, there is no vasodilation, because how our body, for example, we have the hypothalamus. The hypothalamus contains the temperature center in the hypothalamus. So if we have high temperature in our body, how the hypothalamus can know there is a high temperature, if there is no blood. So this high temperature, the blood takes this high temperature through the receptor to the hypothalamus. That is how we maintain the homeostasis through the blood. And after that, the hypothalamus, the efferent or the effector either increases sweating, either vasodilation. These occur also through the blood. So this is the maintenance of homeostasis. The other thing is the control of the pH. Through the buffer of the blood, we have a many buffer in the blood, like we're going to discuss it in the renal system, like bicarbonate, like proteins, like hemoglobin. All these buffer in the blood. So this is the homeostasis. The homeostasis maintenance of constancy of the internal environment. The hemostasis mean maintenance of the blood themselves by self. Okay, prevention, that means prevention of the blood loss and maintenance of the blood in the fluid state. What does that mean? That means the blood, normal blood is a fluid, right? In the fluid state. So when we take sample outside our body, the blood will clot. I think anybody can notice that, like when there is, if someone injured and there is blood loss through that injury, so the blood immediately outside our body will clot. Okay, so to prevent that clotting and prevent blood loss through the either hemoptysis, hematemesis, epistaxis, to prevent that blood loss, that means the blood become more fluid, we have some factor prevent that. So we need the blood in a specific fluid nature. We don't want it to be more fluid to be lost outside the body, and we don't want it to be clotted. So that maintenance of the blood in the fluid state inside our body through the specific factors in our body. So to prevent blood loss, we have a platelet and clotting factor. The platelet and clotting factor prevent the blood loss through the maintenance of the blood in a specific fluid state. And to prevent blood from clotting, we have natural anticoagulant. All these circulate in the blood. Okay, so the hemostasis is different. You should differentiate the homeostasis, the maintenance of internal environment, and hemostasis, maintenance of the blood. Okay, so prevent the blood loss through the platelet and clotting factor, and prevent clotting of the blood, maintenance of the blood in the fluid state by prevention of the clotting through the natural anticoagulant. So this is the functions of the blood: transport, defense by the WBCs, homeostasis, and hemostasis. Okay, so how is this blood formed? The mechanism of formation of the blood is called hematopoiesis. Hematopoiesis is the formation of the blood, either it's the RBCs, WBCs, or platelet. So hematopoiesis is the process of the blood production occurring primarily in the bone marrow, where stem cells differentiate into red blood cell, erythropoiesis, white blood cell, leukopoiesis, and platelet thrombopoiesis. So when the blood synthesized in the bone marrow, the cell called stem cell. That stem cell differentiate either to red blood cell through the erythropoiesis, or to white blood cell through leukopoiesis, or to platelet through thrombopoiesis. We have many sites of hematopoiesis throughout our life. So during pregnancy, in the first trimester, the blood production occurs in the yolk sac. In second trimester, occur in the liver and spleen. And in the third trimester, occur in the bone marrow. It's called red bone marrow. The active bone marrow called red bone marrow, and the inactive bone marrow, it's called yellow marrow. Okay? So we have two types. That means we have two types of bone marrow. We have red bone marrow, the active one, and yellow bone marrow, the inactive one. So the synthesis of the blood occur in the red bone marrow, the active marrow. During pregnancy, that means in the fetus, all the bone of the fetus, it's active marrow, it's red bone marrow. But after the fetus delivered, there is some red bone marrow converted to yellow bone marrow. So after delivery, the blood is formed at the following site, the red bone marrow. Where that red bone marrow? After delivery, the red bone marrow start to replaced gradually by yellow marrow, inactive marrow. It's where exactly by the age of 20 years. That means when the person become adult, the red bone marrow it's found only in the flat bones, in the skull, sternum, ribs, scapula, vertebra, and iliac bone, ends of long bone, small bone of the hands and the feet. That means the long bone like tibia, fibula, radius, radial, and ulna, the shaft, all of this long bone, it's inactive. Okay, but the end of long bones is active or red bone marrow. About 75% of cells in the bone marrow are WBCs, precursor, and only 25% are RBCs, precursor. In spite of that, RBCs count is over 5 times more than WBCs count. This indicates the longer lifespan of RBCs. So inside the bone marrow, in the blood we mentioned, the RBCs occupied more than the WBCs. 90% of the cells in the blood is RBCs. In the bone marrow, 75% of cells is RBCs, and only 75 is WBCs and only 25 is RBCs. This is percentage. In spite that the number of RBCs 5 times more than WBCs. Why? Because we have a long lifespan of RBCs. Okay, the RBCs has about 120 days. This is the lifespan of RBCs. Okay, but the WBCs it's many days, few days. Okay, that is why the RBCs is 5 times more than WBCs. Thank you. Our lecture finished. We're going to continue next lecture. Thank you so much.